Hello friends, in this session we will discuss about the lot of by lot acceptance sampling plan. That is especially there will be focus on the single sampling plan and double sampling plans. Before this we have already studied about the control charts, but here we are focusing on the sampling plans. So what is the basic difference between the control charts and the sampling plan? So in the case of the control charts, we have seen that we have to do the 100% inspection, but to avoid the 100% inspection, if this is the costly type of the inspection and the testing procedure, then we avoid the 100% of the testing. So in this situation we produce a lot, and from that lot we take a sample and we check the quality level of that sample. On the basis of the result of that sample, we decide that this lot should be accepted or this lot should be rejected. So this is based on the probability of the occurrence of the defects in that defective in that sample. That means this is completely based on the probability of acceptance. Now how to deal with and why this is used. If suppose the same repetitive type of the testing is used but there is no automation system, so this is very boring type of the job. So in that situation also we can use the sampling plan in place of the control chart. So these are the some applicability of the sampling plan in place of the control chart. Now we have already discussed that 100% inspection is not possible in the case of the costly item or in the case of the destructive type of the testing. So then we can use the sampling plan and we can minimize the cost of the inspection also. Now, see what are the disadvantages and limitations of the sampling plan. There are risks that accepting defective lots and the rejection of the good lots. So, if there is acceptance of the bad lot to the consumer, then this is known as consumer's risk. This is known as consumer's risk. Consumer's risk. That means the probability of accepting the bad lot, this is known as consumer's risk, and probability of rejecting the bad lot, this is known as producer's risk. That there may be the probability that good lot may be rejected because this is based on the number of defectives in the sample. For example, suppose the lot size is of 5,000 items and we take the 100 items just like a sample, and we check this sample and we say that if the number of defective is equal to or less than 2, then lot will be accepted, otherwise lot will be rejected. So by the way, if the number of defectives in the 100 product is more, then on the basis of that we can reject the entire lot, but there may be the probability that the rest of the items in that lot may be the very maybe of the very good quality. So this is known as producer's risk. So we will discuss about the consumer's risk and producer's risk both, and this is involved in this sampling plan. So this is one of the limitations. Then more time and efforts are devoted in planning and documentation of the sampling plan. Then less information is provided about the product because we do not consider the individual quality characteristics. We consider the overall the different quality characteristics. On the basis of that we decide that this product is acceptable or this project is to be rejected. Now, for the formation of the lot formation and the sample selection, what should we do and what is the procedure? In the lot formation, we should keep in mind that the lot size should be very large and the distribution of the items should be homogeneous throughout this lot, so that we can take, if we take the sample from any part of this lot, this should represent the entire lot, not the specific part of the lot. So the homogeneous distribution of product is required. Then second thing, this sampling selection, how to make the sample. So we can generate the random number. Suppose there are 5,000 products in the lot, and we can provide the numbering from 1 to 5,000 to all the different products, and we can generate the random number manually or using the computer programming. And after a generation of the random number, 100 random number can be generated between 1 and 5,000, and we can take that product for the testing purpose, and on the basis of that we can decide that lot should be accepted or lot should be rejected. So this is the method of the lot formation and the sample selection. There may be the different types of the sampling plan. This may be the single sampling plan, double sampling plan, and multiple sampling plan, and one more. This is known as the sequential sampling plan. So here we will discuss about these two. This is very similar to the double sampling plan, but we increase the number of samples. Here, in the case of the single sampling plan, we take a sample from the lot, and on the basis of the result of that sample, we decide that this lot should be accepted or this lot should be rejected. But in the case of double sampling plan, if the number of defective is more than the acceptance number but less than the rejection number, then in that situation we have to consider the second sample. So it depends on the design of the sampling plan. For example, this is the lot size. This is given as n equal to 5000. 5000 items are there in a lot, and we take n equal to suppose 150 product, and it is given that c equal to 2. C equal to 2. That means this is designed for the single sampling plan, and we take the 150 product out of this 5000 product, and we check the quality. If the number of defective is less than or equal to C, less than or equal to C, then the lot should be accepted, otherwise lot should be rejected. That means if D is greater than C, then this lot should be rejected. This is known as single sampling plan. But in the case of the double sampling plan, we design in such a way that 5000, suppose N1 equal to 500, C1 equal to 2, and R1 equal to 5. That means if the number of defectives in the first sample, that is D1, is less than equal to 2, then the lot should be accepted. Lot should be accepted, and no need to draw the second sample. No need to draw the second sample. But if the number of defective is in between 5 and 2, 5 is the rejection number. That means if the number of defective D1 is equal to 3 or this is equal to 4, then in that situation or 4, in that situation we have to consider the second sample. Second sample means N2. N2 maybe suppose 200. Then we can decide that suppose C2 equal to 5. C2 equal to 5. Then the total number of defective, that is defective in the first sample plus defective in the second sample, must be less than equal to 5. Then the entire lot will be accepted, otherwise the entire lot will be rejected. But in the first sample, it must be less than equal to 2 if you want to ignore the second sample. But if the number of defective in the first sample is equal to in between R1 and C1, that means 3 and 4, then we have to consider the second sample. So this is the method. And suppose this is a R2 equal to suppose 6, then there is no need to find the third sample. But suppose R2 equal to 8, then if we consider that D1 plus D2 is more than this, that means 6 or 7, then we have to consider the third sample. This is now case of the multiple sampling plan. So in this way the number of samples can be increased in the multiple sampling plan. But here we will focus only on the single sampling plan and double sampling plan. Now this is the concept of the single sampling plan I have shown in this flow chart. Inspect the n items out of capital N lot. Then if the number of defective in this sample is less than or equal to the acceptance number, that is C, then accept the lot, and if it is greater than C or more than C, then reject the lot. So this is single sampling plan. So how to do this? This is based on the Poisson distribution. And here C is the acceptance number, and we want to find that the number of defectives should be C or less than C. C or less than C. That means we can write C or less. So we want to find the cumulative type of the probability of acceptance. So this PA will be indicated by NP0 divided by factorial C e to the power minus NP0. Here N is the sample size, and E is the sample size, and P0 is known as process average. Process average is shown in terms of the percentage error or something. So this can be written here, the 100 P0. So if we consider that 1% error, then we can write the P0 value is 0.01. And if we consider 1.5%, then P0 value will be 0.015. After multiplying it with 100, this will be 100 P0, and we find the probability of acceptance considering for C or less, and then this PA value is plotted between the 100 P0 and PA, and we can find the different value here, and we can plot this curve, and this is known as OC curve, and this is also known as operating characteristics curve. This is known as operating characteristics curve. So this PA is probability of acceptance C1 or less. Now see this numerical example. Here we have considered the different value of P0. We should consider the P0 value between the 0 and 5% or 6, because if we consider more than this, then the PA will be very close to 0. PA will be very close to 0 or tends to 0. So there is no need to do such a large number of calculations here. But here I have done up to 7%. Now this is the 100 P0. 100 P0 is used for the x-axis, 100 P0, and this is the NP0. Here, by the way, n and 100 both are taken same for the calculation simplicity. So this value both are same here, but we can take any value of n as given in the question. And here C equal to 2. So the how to take this value PA? How to take this value PA? This value can be taken from the Poisson distribution table. So you can see here this Poisson distribution table. I think I have used here. This is the Poisson distribution table. Suppose C is given as 2, then for different NP0 value, this is the NP0 value, NP0 value, NP0 value, NP0 value, NP0 value. So this is given for the different NP0 value. This NP0 value is given in the index of the Industrial Engineering and Management, written by me at the index, and this is up to the 15, NP0 equal to 15. So you can use the larger value also. So if C equal to less or this, then you should take this value, not the outside value. This is the exact value, or you can say that absolute value. The bracket term shows the cumulative value of the parenthesis. In the parenthesis, this is the cumulative value. Cumulative value means if you want to find the number of defective 2 or less, then this may be the P1, P0 plus P1 plus P2. So this is the probability of acceptance. If the number of defective is 0, 1, 2, then this is a PA. If this is more than 2, then this is rejected. So PA will be equal to 1 minus PR. So this is if considered the probability of acceptance. If it is indicated as 1, then if you find the exactly 2 defective, then in that case we can take the outside value. This is the absolute value. Absolute value means what is the probability that in this sample there will be exactly 2 defective, then we can take the outside value. If we say that what is the probability that the number of defective will be 2 or less than 2, then for PA value we should take this bracket term value. Now this is the difference. So we can see that this PA is the cumulative value if this is bracket term value, and if we want to find exactly 2, then we can write this PA minus P0 plus P1. That means if PA is equal to 1, then 1 minus P0 plus P1 we can write. So PA value is taken from this bracket term. This is the cumulative value, and in this way we can take the help of the Poisson distribution table. Now see here for the single sampling plan how to do this, and this value can be taken for the different value of NP0 corresponding to C equal to 2, and this should be the cumulative value, and we can take this cumulative value and we can plot here like this, and we can draw the OC curve. So this is PA. At the 0 point, this will be 1. So if there is no defective, the probability of acceptance will be 1. So there is 1, and in this way we can find the different value of probability. We can draw the OC curve. This is the OC curve for that problem, you can see here. Now in the next case, for the chart of the double sampling plan, we have discussed the mechanism of the double sampling plan. If the number of defective D1 in the first sample is less than C1, that means this is the n equal to something, and n1 is the sample size of the first sample, and C1 is the number of the acceptance number based on the first sample, and R1. And second sample, this is n2, and C2 is the acceptance number. Then in that case, if the number of defective in the first sample is less than or equal to C1, then no need to draw the second sample except the lot. And if the number of defective is more than this R1 or equal to R1, then we should reject the lot. Again second sample लेने की कोई जरूरत नहीं, and we cannot consider this second sample here. So here you can see that D1 is greater than the acceptance number C1, then reject the lot. So we can reject the lot. Now in this case, when we should consider the second sample, if the number of defective is in between the C1 and R1, in between C1 and R1, then take a second sample of the size N2 and inspect them, and now consider the defective D1 and D2. D2 is the defective incurred in the second sample. So if D1 plus D2 is less than C2, then accept the lot. And if D1 plus D2 is greater than C2, then reject the lot. Now see the numerical example on this problem. So this is the probability of acceptance, and this is the probability of acceptance based on the first sample, and this is probability of acceptance based on the inspection of the second sample. But this is conditional. This is conditional. This will be used only when the number of defective in the first sample is in between C1 and R1. So here you can see that PA1 will be PC1 or less, PC1 or less, which we have already discussed in the first example. So this is based on this single sampling plan. Now PA2 will be conducted when the number of defective in the first sample in between C1 and R1, then we can take this. Suppose if we consider that this numerical problem here, draw the sampling plan. If given n equal to 3000, this n1, the n1 is sample size, this n1 of the first sample is 200, and C1, this is the acceptance number of the first sample, this is given as 2, and R1 is 5, and second sample size is 250, and C2 is 5. That means if the number of defective in the first sample D1 is less than equal to 2, no need to use the second sample. But if D1 is equal to 3 or 4, then we have to find the second sample. If D1 is greater than or equal to 5, no need to draw the second sample and reject the lot. This is accept the lot. Okay. Now when we should use the second sample, if the number of defective in the first sample in between C1 and R1, that means 3 or 4, then we should use the second sample. So in the second sample, for the acceptance, how many defects will be there? If suppose D1 is already occurred in the first sample, this is equal to 3, then this can be accepted only the maximum defect D1 plus D2 is equal to 5. So in the second sample, D2 should not be more than 2. That means this should be less and equal to 2. Then the total defect will be 5 and less than 5. And if suppose D1 is 4, number of defective in the first sample is 4, then in the second sample the maximum defective can be considered less and equal to 1. Then in that situation the maximum number of defective will be only 5, and the lot will be accepted. So in the second case you can see here PA2 will be P3. P3 means P3 means exactly 3 defective in the first sample, and P2 or less, this is P2 or less in the second sample, and P4 means exactly 4 defective in the first sample and 1 or less in the second sample. So in this way we can find the value of PA. PA will be equal to PA1 plus PA2, and this will be PA. So probability of acceptance, combined probability of acceptance, or you can say that probability acceptance in the double sampling plan will be PA1 based on the first sample and PA2 based on the second sample. So both must be added here to find this. Now this concept is used here. You can see this table. I have already explained that how to take the value. Now you can see here we have considered the different value of P0 as usual in the sampling plan we have already discussed. Then this is 100 P0, this is N1 P0. Here N1 and N2 are different, therefore we have to write N1 P0. And from the first sample, based on the first sample, what are the different value are to be taken? PA1, that is this should be the C less than equal to 2, and then this one, that means exactly 3 defective in the first sample, exactly 3 defective in the first sample, and this will be calculated based on N1 P0. And this is also P4 exactly in the first sample, this will be calculated based on the N1 P0. Now you will have to find the N2 P0, and for the second sample we have to find the P2 or less from the second sample based on the N2 P0, and P1 or less based on the N2 P0, and finally you will have to find using that equation PA2, and this is PA2, and after adding this PA1, this PA1 and this PA2, and we can find the value of PA. So this is value of PA, and we can plot here. This is the value of PA, this is value of PA, and this is value of PA1. So in this way we can plot the double sampling plan. Now see the property of OC curve. What is the property of OC curve? Here this is the OC curve. Just 1 minute. Now see this OC curve. If we use this OC curve like this, then what is the property of this OC curve? So we can see that for sample size as fixed percentage of lot size, that is 10% of the lot size, that maximum it value should be 10%, not more than the 10%. Curves becomes steeper. If we increase the sample size, then curves becomes steeper like this. Then second property, for fixed sample size, if n is fixed, curve becomes similar to each other for n equal to 10% of the capital N. That means the sample size is 10% of the lot size, and for identical value of n, this will be very similar to each other like this, very close to each other. Now for increasing sample size, curve becomes steeper. If we increase the sample size, then curves becomes the steeper like this. For the increasing sample size, this sample size will increase in this direction. Now for decreasing acceptance number, curve becomes steeper. For decreasing, if the acceptance number decreases, then again it will be steeper. So these are the properties of the OC curve. Now there are two types of the OC curve. One is known as type A curve, and other one is known as type B curve. Type A curve is used for the isolated finite lot size, that means fixed lot size. But if there is continuous production, or we can say that infinite lot size, then we can use the type B curve. So this is type B curve, and this is based on the binomial distribution, but type A curve is based on the hypergeometric distribution. You can see here, this is based on the hypergeometric distribution, this one distribution. is used to calculate the acceptance. But this binomial distribution is closely approximated to Poisson distribution. Therefore, we use in place of the binomial distribution Poisson distribution. Now, type A curve increases, it approaches the type B value. That means a type A curve will be very close to a type B curve if the sample, if the lot size increases. Lot size increases. So if the lot size is very large or the sample size is very large, then in that case it will be very close to the type B curve. Now here you can see here the nature of type A curve and type B curve. So this is type B curve because the sample lot size is infinite. Here the lot size is finite. So this is the type A curve, and this is based on the hypergeometric distribution, hypergeometric distribution, and this is based on the binomial distribution, binomial distribution, and it is approximated to the Poisson distribution. Now this is consumer producer relationship. If there is 100% inspection, this is acceptance quality level, and if there is 100% inspection, then this is probability of acceptance. This is 100%. But if there is no 100% inspection, we use the sampling. Then in that case, this is the acceptance quality level, and up to this acceptance quality level, there is risk. This is known as the producer's risk, producer's risk, and this is indicated by alpha. Alpha, the value of standard value of alpha is approximately 0.5, but it may vary from 0 to 1, 0 to 1, but standard value of alpha is 0.5. That means if there is 5% producer's risk, the 5% producer's risk means the probability of rejection of the good lot, probability of rejection of the good lot. So this side, this shows the probability of rejection of the good lot, but this is probability of acceptance of the good lot. This is 95%, 95%. So probability of acceptance considering the producer's risk, considers producer's risk will be 1 minus alpha. This 1 minus alpha, 95% is probability of acceptance, and this alpha indicates the probability of rejection of the good lot. So this is the producer's risk. Similarly, this value shows the beta. Beta in terms of the probability of acceptance of the bad lot, probability of acceptance of the bad lot. So this is taken normally 10%. This is 1. So there may be the probability that the bad lot may be accepted, and this is known as LQL, that is a limiting quality level. This is accepting quality level. This limiting quality level is also known as lot tolerance percent defective. Lot tolerance percent defective. That means the quality level corresponding to the consumer's risk is known as LTPD or LQL, and the quality level, accepting quality level corresponding to the producer's risk is known as AQL. Now, thank you. We have completed this single sampling plan and the double sampling plan. And now we will continue this lecture session considering the other topics of the production and operations management and the quality management.